All right, continuing. Number 5, we've got function f from 0 to 7 with 4 line segments as shown. G is given by, g of x is the integral from 2 to x of f of t. And like they always kind of throw these things in there and they really mean the whole problem. Like here's f, but really here's what we want to work with is g of x. So A says find g of 3, g prime of 3, g double prime of 3. Let's just put numbers in. G of 3 is the integral from 2 to 3 of f of t dt. So what does this want? The area under f of t from 2 to 3. So we go ahead and we can do a trapezoid, probably just count. The area there is going to be 3. G prime of x from the fundamental theorem of calculus is going to be f of x. So g prime of 3 is just going to be f of 3. f of 3 is 2. G double prime of x should be f prime of x if this was the case. So g double prime of 3 equals f prime of 3. The derivative of f at 3 wants to know the slope of f at 3. Here is the slope of f at 3. It goes down 4 over 2. So the slope of f at 3 is negative 2. Great. The average rate of change of g over the interval from 0 to 3. And g is the integral from 2 to x of f of t. So really, if I want to find out how much something has changed, I can just find out where it's gone. G of 3 minus g of 0 would be how g has changed. The average of that would be over how long. So g of 3 we found in A to be 3. G of 0 over here, it's kind of neat, is the integral from 2 to 0 of f of x, f of t. So I'm looking at this area here. And remember, so our base is 2, our height is 4, 2 times 4 divided by 2. The area there is 4, but when I go backwards, when I go from 0 to 2, I get a negative area. So it's really 3 minus negative 4 over 3. So that's going to give me 7/3 would be my average value of g on that interval. And for how many values c from 0 to 3 is it equal to the average rate? So the average rate was 7/3. How many times is g prime equal to 7/3? G prime was equal to f, so really we just look in our graph. 10/3 is 7/3 is 2 1/3, so that line is right here. So how many times does g prime equal 7/3? Good justification for that would just be by the graph, somewhere between 1 and 2, and between 2 and 3. So it equals that 2 times. G is going to have a point of inflection whenever g double prime is 0 and changes from positive to negative or negative to positive. G double prime of x equals f prime of x. So really we can just concentrate on the slope of f. the slope of, so f prime is 2 from 0 to 2. It's negative 2 from 0 to 4. It's negative 1 from 4 to 5. And it's positive, looks like it's positive 1 from 5 to 7. So f prime of x is greater than 0 from 0 to 2. F prime of x is less than 0 from 2 to 5, really. F prime of x is greater than 0 from 5 to 7. So because it goes from positive to negative, and then it goes from negative to positive, there will be 2 points of inflection on the graph of G. They would occur at 2 and 5.